Hello everyone, I am Abhishek HR. I welcome back to the online session on dynamics of machines. We were discussing about several masses on different plane in the module 2, that is balancing of rotating masses. In the previous session we have solved a numerical problem in which we have find out the magnitude and angular position of the balancing planes. So next we will move on to the second problem, that is problem number 2. A rotating shaft carries 4 masses 1, 2, 3 and 4 which are radially attached to it. A rotating shaft carries 4 masses 1, 2, 3 and 4 which are radially attached to it. So, there are 4 masses. The mass centers are 30 mm, 38 mm, 40 mm and 35 mm respectively. So, these are the radius of rotation of the all 4 different planes, that is 30 mm, 38 mm, 40 mm and 35 mm. If we have 4 masses means we have 4 planes. So, for all the 4 planes radius of rotation are 30 mm for plane 1 and for plane 2 38 mm, for plane 3 40 mm and for plane 4 35 mm radius of rotation. Then from the axis of the rotation, the masses 1, 3 and 4, the masses 1, 3 and 4 are 7.5 kg, 5 kg and 4 kg respectively. Only we have mass values of plane 1, plane 3 and plane 4. The axial distance between the planes 1 and 2 means the distance between plane 1 and plane 2 is 400 mm and 2 and 3 is 500 mm. The masses 1 and 3 are at right angles to each other. So, this is a very important line in this problem. The masses 1 and 3 are at right angles to each other. Find the complete balance. First one, angle between 1, 2 and 1, 4 means theta 2 and theta 4. Angular positions of plane 2 and angular position of plane 4. Axial distance between 3 and 4, the distance between 3 and 4. So, that we need to find out, because they have given the axial distance between the planes 1 and 2 and 2 and 3, not given the 3 and 4. So, that we need to find out. Magnitude of the mass 2. So, as per the problem statement, we have the masses for 1, 3 and 4, not for the 2, plane 2. So, for that we need to find out the mass. So, this is the given problem. See, before going to solve it, just recall the previous problem. In the previous problem, you have all 4 masses, you have the angular positions of the all different planes. Only the thing is you need to find out the angular position and the magnitude of the balancing plane. But here we do not have any such type of balancing plane. We have only the planes of 1, 2, 3 and 4, not any other balancing planes. That means in all the 4 planes for a system, so something is disturbing. So, to balance that we need to find out the magnitude of mass 2 and the axial distance between 3 and 4 and the angle between 1 and 2 and 3 and 4. For this problem they have not given the angular positions of the other planes, but they are clearly mentioning that the masses 1 and 3 are right angles to each other. So, this is a hint in the given problem, that is plane 1 and plane 3 are right angles to each other, which means the planes are at 90 degree. So, that is the hint given in the problem. Using that hint we need to solve the problem. Okay, now let us solve the problem. So first thing is we need to show the planes. So we have 4 planes, plane 1, plane 2, plane 3 and plane 4. So I have told in the previous problem that if we have 2 balancing planes, we need to consider any one of the plane as reference plane. But here we do not have any balancing plane, we have only 4 planes. So in such condition, we need to take any one of the plane as my reference plane. So here I have 4 planes, I will consider 2 as a reference plane. Why? Because I will get a more positive value or the positive magnitude while solving the step. 2 is considered as reference plane, Now as per the problem statement, the axial distance between the planes 1 and 2 is how much? 400 mm. 1 and 2 is 400 mm. 1 and 2. Then 400 mm and 2 and 3 is 500 mm. 2 and 3. 2 and 3 is 500 mm. 2 and 3 is 500 mm. We know the distance values from 1 to 2 and 2 to 3, that is it from the given data. But we do not have the distance from distance of the plane 4 from reference plane 2. We do not know. So let us call this distance as x, because we do not know the distance from reference plane 2 to 4. So I will just consider it as a x. Later we can find out. So this is the given plane as per the problem. Now we need to construct the space diagram now. Space diagram. So as I already told in the previous problem, it is a rough sketch to indicate the angular positions of the different planes. So initially the first plane will be in the 0 degree condition, right? Then we have mass 2, mass 3 and mass 4, but we do not know the angular position. But we know that the masses 1 and 3 are at right angles to each other, which means mass 3 is at 90 degree. Mass 3 from the plane 1, plane 3 from the plane 1 is at 90 degree, because it is clearly given that mass 1 and 3 are right angles to each other. Then rest of the angles we do not know. We do not know theta 2, then we know also we do not know the value of theta 4. So maybe it will come here M4 and M2 and M4. This will be theta 2, this will be theta 4. Because we do not know the exact location now, so I am just indicating roughly at certain position. So later on we will find the angular positions of the plane 2 and plane 4. So these are the data that we have extracted from the given problem. So our next step is we need to construct the tabular column. Now in the tabular column we need to enter all the values that we have extracted from the given problem. So first column is about plane and second column is about mass is in kg, then radius of rotation, so it is in meter. The radius of rotation are given in mm in the problem statement, but while entering in the tabular column we should convert it into meter. Then force, so that will be in kg meter, then distance from the reference plane, so that will be in meter, then couple force into distance kg meter square. Now we have plane 1. The mass of the plane 1 is 7.5 kg, 7.5 kg. Then the radius of rotation of the plane 1 30 mm, 30 mm means it is 0.03 meter. Then we have second plane, but they have not given the mass for the second plane, so I will just considered as m2, but they have given the radius of rotation for the plane 2, that is 38 mm. So it will be 0.038 meter, 0.038 meter. Then we have plane 3. Plane 3, for plane 3 the mass is 5 kg and the radius of rotation is 40 mm, means 0.04 meter. Then we have plane 4 and the mass value is 4 kg. Then radius of rotation is 35 mm, means 0.035 meter. Okay. Now for the force, mass into radius, 7.5 into 0.03 will be 0.225 kg meter. Then m2 into 0.038, 0.038 m2. Then 5 into 0.04, 0.2, and 4 into 0.035 will be 0.14. 0.14. Now the distances from the reference plane, plane 1, the distance of the plane 1 from the reference plane, here my reference plane is 2. So from reference plane 2 to plane 1 the distance is 400 mm, which means 0.4 meter, not only 0.4, minus 0.4, because our distance is towards left hand side from the reference plane. Then plane 2, since I have considered plane 2 as a reference plane, so the distance will be 0. Then plane 3, so plane 3 from reference plane it is 500 mm, so it will be 0.5 meter. Then for plane 4, see for the plane 4 from reference plane we do not know the value, I have considered x, so I will just write as x. Now for the couple, force into distance, so 0.225 into minus 0.4 will become minus 0.09, and for the plane 2 it will be 0 since we have distance 0. Then 0.2 into 0.5, 0.1, then 0.14 into x, 0.14 x. So now we have completed the tabular column part. We have entered all the planes and the masses of the respective planes, radius of rotation of the respective planes, force values, distance from the reference plane values, and the couple values. So our next step is we should construct the couple polygon and force polygon so that we can find out the required parameter. Now first we will construct the couple polygon. Couple polygon. Now we have the couple values here minus 0.09, 0, 0.1, 0.14x. We have only two completed magnitude of the couple values, that is minus 0.09 and 0.1. 0.14x we do not have the complete magnitude, and here it is 0, so that I cannot consider 0 for the construction. So I have only 0.09 and 0.1, plane 1 and plane 3. That is why they have given in the problem statement the planes, the masses 1 and 3 are at right angles to each other, which means the angle between 1 and 3 is how much? 90 degree. So using that hint we can construct the couple polygon. Okay, now let us start the construction. Just take a scale. So I will take 1 centimeter is equal to 0.03 kg meter square, so that it will be easy to construct. So now take your scale and measure the or convert the couple values for your taken scale, then use your converted readings and draw a line of couple value 0.09. Since it is a negative value, you should be start towards left hand side. So for this 0.03 means 0.09 by 0.03 will become 3 centimeter. Draw a line of 3 centimeter. Towards left hand side, and take your protractor and measure the 90 degree. Take your protractor, put on point A, so measure 90 degree. 90 degree means it is a straight line for your converted scale. So it will be point B 90 degree. So it is minus 0.09 kg meter square. It is 0.1 kg meter square. Now we have 2 points, starting point O and the end point B, because we do not have any other angular position of the plane to locate or move on for the next step. So I have used the given hint, the right angles each other between 1 and 2, between 1 and 3. So now I got the construction like this. Now just close the starting and ending point. So this will be 0.14x. So this will be 0.14x. So first I have taken the 0.09 means converted scale means 0.09 by 0.03 3 centimeter, and I have taken the 3 centimeter line. I have a hint that is right angles to each other of the 1 and 3 plane. So I have taken 90 degree angle, then I have a value couple value 0.1. For the converted scale I have drawn a line, then I have just closed the starting and ending point to make a polygon. Now measure this distance O and B or B and O. So that will be is equal to your 0.14x. OB into scale is equal to 0.14x. 0.14x. Measure the distance and multiply with your scale, and if you simplify this you will get x is equal to 0.96 meter. So if you say in mm, it will be 960 mm. So this is the x value, and also measure this angle theta 4. Measure this angle. So take your protractor and put your protractor like this and measure the angle of the plane 4, that is the theta 4. So for that, so the theta 4 will be 312 degree. Around you will get 311 or 312 degree. So, this is the angular position of the plane L. Now, I got the value of x and also the angular position of the value theta 4. Now, let us move on to the force polygon now. Force polygon. For this also you need to take a scale, take the same scale only. 1 centimeter is equal to 0.03 kg meter square. Dear students, I am just doing the problems on board to explain you, but when you are doing, take a proper scale reading and measure the proper distance and also measure the correct angle. So, you will get a correct answer. Then coming to the force polygon, we have a values 0.225, 0.38 m2, 0.2, 0.14. We can't take 0.038 m2 because we do not know the mass value of plane 2. We have other 3 values and also we have 2 angles now. One is 90 degree and one more theta 4 is 312 degree. So, using this data we can construct the force polygon. Now, for this 0.225 by 0.03 kg meter square. So, for the converted scale, draw a line. .225 kg meter towards right hand side, since we have a positive magnitude. Okay. So, then we have a angular position of 1 and 3, that is 90 degree. 90 degree means it is a straight line. So, draw a line with respect to your plane 3, 0.2. For the converted scale reading, draw a line. So, this will be 90 degree and this point will be B and this is 0.2 kg meter. 0.2 kg meter. Then we have the angular position theta 4, that is 312 degree, that we have extracted from the couple polygon. Just make use of this angular position, put your protractor here. I will just show you how to take the angle from this point. So, put your protractor like this. What is the angle? 312. So, 312 means it will be here and the distance is how much? 0.14 and for the converted scale, so this point will be C, 0.14 kg meter. Clear? So, I have taken all the angular positions 90 degree as well as the 312 degree. While constructing the couple polygon and force polygon, for each and every step you need to denote it by some terms like O, A, B, C, D like that, and also you need to mention the direction, in which direction you are continuing with the magnitude values. Then also you need to represent the actual values of force and couple. So, now this is my end point. Thereafter I do not have any other angular position values. Now I will just close the force polygon now. This is the end point and this is the starting point. So, this is what your 0.038 m2, 0.038 into m2, and this angle is theta 2. This angle will be theta 2. Now, measure this distance OC or CO. So, measure this distance multiply with your scale is equal to 0.038 m2. 0.038 m2. Now, if you simplify this, you will get mass to around 8.74 kg, or maybe you will get 8.5 kg or 8.6 kg, you may get like that, but it should be around 8.57 or 8.56 kg. So, this is the mass of the plane 2. That is what they have asking us to find, magnitude of mass 2. Magnitude of mass 2, that is what m2 is equal to 8.74 kg. Now measure this angle, put your protractor over here, measure this angle, you will get around 195 or 196, somewhere around. So I will take 196, theta 2 will be 196 degree, theta 2 will be 196 degree. Now we got all the values as per the required parameter in the given problem. So this is force polygon and this is the couple polygon. So as per the problem, angle between 192 and 194, magnitude of mass 2 and the axial distance between 3 and 4. So we have got almost all the values, but here in the given problem we need to find out the axial distance between the 3 and 4, means 3 and 4, but what I got, the value of x is from 2 to 4. So from 2 to 4 I have considered as x. So x is 0.96, but what I want is 3 and 4, the distance between 3 and 4. So for this you just minus, means 960 mm minus 500 mm. So you will get 0.46 meter. 0.96 minus 0.5. So you will get 0.46 meter. So this is the axial distance between the plane 3 and 4. 3 and 4. This is the a different problem with respect to your first problem, because in the first problem it is like a direct question. They have given each and everything, you have to just find out the magnitude and angular position of the balancing planes. But in this problem they have not given any balancing planes, they have given only the 4 planes. In those 4 planes only we need to consider any one of the plane as reference plane, and from that hint we need to construct the couple polygon as well as force polygon, and from that we need to find out the required parameter. So in the similar way for any other different kinds of problem also you can solve like this. Your first duty is to read the statement, problem statement carefully, read it 2 to 3 times and understand the problem statement and list out the data given in the problem statement, so that you will get an idea how to solve and what are the parameters that we need to find out and what are the hints given in the problem. So like that, so after that construct a plane for the given distance in the problem, then just draw a rough space diagram. From the space diagram you will get to know the angular position of the planes. Then construct a table. If you construct a table means you can solve problem easily, because from the table only, from the table we are going to consider couple polygon, we are going to construct couple polygon as well as the force polygon. So tabular column is important. Now then in the couple polygon, so you will get the angular position of any one of the plane. So with reference to that you can construct the couple polygon, force polygon, and in force polygon also you will get the angular position of the any one of the remaining plane. So like this you can solve the problems on several masses on different plane. Thank you.